will be filtered.
Like,
Huh?
slide 1 second.
Can you hear me? Audio is ready.
Hi everyone. Hello.
Hello.
Good evening.
Good evening.
We are starting at a time which is actually pre-evening or post-afternoon, so it's really kind of bizarre. But thank you everyone for making it to the event. First of all, huge round of applause to all of you for welcome to MOI DevX Goa. This is actually one of a kind, first ever boot camp that we as the MOI team are hosting to help developers and industry colleagues from the Web3 as well as Web3 industry come from different walks of life to learn what MOI is up to, learn a new smart contract language, and explore some new ideas and understand how there are backings ready for you guys to build on top of MOI. So are you ready? Yes. Then ask it one more time. Are you ready?
Yes.
One more time.
Yes.
Ready? I thought they guys gave you a good lunch buffet, no? At Web3 conference, no?
No.
Are you not sure? I'm going to ask one more time. Are we ready?
Yes.
Alright, let's get started. So, thank you so much. We'll start off with the community deck while others join in. So, let me first share the vision of our team. Our thesis is kind of very simple. We don't want to start off as just another Web3 scalability solution on top of Ethereum or some other L1, right? So instead of just blindly taking one step ahead and ahead and ahead, let's actually take 10 steps back, right? Let's go all the way back to 2008. So today's internet basically gets most of your job done. You have so many platforms, products and services like Google, Dropbox, Twitter and PayPal, which help you search, store, share information, and even to get some kind of information, you already have the payment infrastructure, which gets most of your job done. But this convenience is actually coming at a cost of ownership and control. Whose ownership exactly? Your ownership. Your ownership as a user, or your ownership as a developer who is actually building on top of Web2 platforms like this. So, how can we fix it? Right? So this is where Web3 came into picture. So before I actually start explaining this, I'm going to have a quick show of hands. How many here hold Bitcoins or actually use Bitcoins? Alright, I see at least 40 to 60% of the room. That's really cool. How many here use Ethereum at least on a day-to-day basis or at least weekly, not daily? Cool. Tesla is also okay. I see at least 30 to 40% of How many here have used file storage services like IPFS, Filecoin, storage, CR, Heartbeat, content address databases, anything else, right? Perfect. I think you got the right crowd here, so I think you're going to blow your minds up. Alright, so how many here have also used some smaller implementations of Ethereum or other blockchains like Lightning or Polygon or Arbitrum recently? Alright, I see that most of you guys have made your money on top of the Arbitrum airdrop. I'm pretty sure. I can see the happy faces like. Alright, cool. So the problem with most of these Web3 technologies are that while their intentions to solve the problems were almost right, they missed a couple of pointers in Web3. If you look at Bitcoin, which was proposed by a group of computer scientists, Satoshi, right? Satoshi Nakamoto, they proposed Bitcoin as another alternative cash, electronic cash payment. But if you look at some of the fundamental data points there, 0.01% of the wallets in Bitcoin network own more than or close to 60% of the bitcoins in the entire network. Not even traditional or fiat systems today have this kind of centralization of wealth creation. And there are only 2 million or close to 2 million bitcoins left to be mined. And out of the 19 million or so bitcoins which are already live in the network, 60% of the bitcoins are already owned by less than 0.01% of the top riches already. How can we assume that Bitcoin can assure us a more default, from the fresh kind of a monetary system for an equal financial system, right? This is not gonna happen. The fact says it off. But then let's fast forward to Ethereum. Ethereum came in and said that there should be no singular currency. We all should develop our own tokens, our own currencies, and use it in our own dApps, right? How many here have ENS domain names? .eth names? Less than 10% of the room. Less than 10% of the room here owns ENS. So when you guys renew your domain, how much do you pay in gas fee other than the ENS renewal itself? You will pay double. Sometimes you pay even actually 5 times the kind of money, right? Sometimes I've paid $50 during COVID times because board apes had just come out in 2020, right? I've also paid $20, but I've never paid anything less than $20. But if you go to GoDaddy today and purchase a domain or renew your domain, GoDaddy won't say that your domain costs 1,000 rupees, but pay me again another 2,000 rupees. Or some other internet provider won't ask you for that. This method of free internet or free market is a cool idea, but so far the efforts that has gone into something like this in Ethereum has made it a bit unreliable, don't you guys think? On a day-to-day level. So let's solve for that, right? So that's what Polygon tried to do with Mantic. Reduce the number of nodes to 100 nodes, and then everything will become unpredictable. While this has worked out for Polygon and other side chains, L2s and rollups in a very, very short term, by having either one sequencer, which will basically submit all transactions from L2 to L1, or by having a side chain with 100 nodes, which will just make it easy for developers and users. But the decentralization message is lost now. And according to Trade-off Bills, the Nakamoto coefficient for most of these L2 sidechains and rollups are very low. Very few companies basically dictate the entire network and how it is basically controlled. So the picture I'm trying to paint here is that Web3 has done a good job so far, but it could have actually done better. But how do we do better, right? So a lot of people say, build another L3, maybe L4, L5, L69 maybe in the next 10 years. But that's not the real approach. Instead of just taking one step ahead blindly, we should actually retrospect and take 10 steps back all the way to Bitcoin and understand why we have arrived here. And that's exactly what we have done as a team. And this is our vision. Our vision at MOI is to build an end-state internet with the help of our technology, which enables billions of participants or internet users to come together and host a crazy amount of millions of number of nodes. And then with this kind of a network form, we want them to trade, define and exchange trillions of different types of assets, digital assets. It could be a retail, it could be an institution, it could be a community, it could even be an organization which is trying to take donations. All different types of assets of industries must be able to manage their assets. And while doing all these things, they should still be able to retain their ownership and control of their identity and data alongside assets. So this is the vision that MOI has. So how do we make it happen? Instead of building on top of Ethereum or Bitcoin, we have built our own technology from scratch. It's a layer 0 technology called as interaction state machine, ISM. Think of it like how Ethereum runs on top of EVM. MOI runs on top of ISM. Right? ISM will be the next generation and will take over, the limitations of it. On top of the ISM technology that we have built at a layer 0, we have introduced our own peer-to-peer network, which is a layer 1 network called MOI. So this is a very quick highlight. We don't want to go too technical into this. I know you are here to actually learn a new smart contract language, so we'll get to that. But why should you actually learn this language? Why should you spend or invest your next 3 hours or 4 hours in this venue? Right? This is a quick comparison and an answer to your question. Right? While we all have been using Solidity, I'm a Solidity user since 2016, right? While we guys have been using Solidity and appreciate what it has done to the community in the short term, we also need to identify the key differentiators which will help blockchain succeed in the long term. And those tracks or facets through which we can look at that are through performance, cost of business, basically fees on a day-to-day transaction, and then reliability, like how distributed is this network really? Is it some sort of a one sequential network or 100 node side chain, or is it actually a network made up of thousands of nodes hosted by real people and institutions and organizations who have performed KYC, performed KYB, and ready to risk their reputation if at all they play any foul in the network, and of course have the ability to truly differentiate between a $10 Starbucks coffee transaction and a $1 million transaction to maybe buy this hotel in the future, one of two rooms, right? So this is a very simple question again, right? You guys, some of you, 30 to 40% of this room, raised your hand saying that some of you actually use blockchain on a day-to-day basis, right? You might have also built apps or dApps. Can somebody tell me if you have seen so far in blockchain an ability to differentiate a $10 Starbucks coffee transaction and a $1 million real estate NFT transaction or any sort of property transaction on the blockchain? Why? That's the question we will answer in this, and Manish will take over on that in some time. And also make sure that the developer experience is pretty good for all of you guys instead of having limitations like stack to view. So without any shame, let's raise hands. How many people here have coded in such a way that Solidity ultimately shows you stack to deep error? Alright, we'll see the end of the tunnel in some time. So MOI makes all of this happen with patented technologies. We have 2 patents that are approved in the jurisdictions of United Kingdom and of course India. And we also have patents in a couple of other countries to prove that we have actually thought about this technology and solve for some ideas from scratch, right? So these are the patented technologies that are now currently enabling MOI. So maybe it's not visible here, but this deck is one of your go-tos after the meetup, so feel free to go through it, and we have to conduct more webinars and catch us online. But the left side is actually the patent technologies. The right side is basically engineering components that basically make up the MOI protocol. You can take a look at it later. And that's where actually the 10 steps, taking 10 steps back actually comes into the picture. All of that is happening because of the R&D for the past 5-6 years. But let's fast forward to the future now. With MOI, what can you actually do, right? With MOI, you'll be able to manage trillions of different types of digital assets and make sure that billions of participants can use this technology and handle their assets. It could be a shopkeeper or a street hawker who can actually use MOI to the same degrees and depth of something like UPI, which you can see today even in a small Chinese shop or a gobi shop in Goa, to all the way to a big institution which also accepts in UPI. So that's something we want to enable. But all of these things are somewhat available in India already with some technologies like I already mentioned. So why do we need to rewrite the story? Because you are not owning any of this right now. They can pull the plug tomorrow and it's all gone. Your credit history, gone. Your identity, gone. Your data, gone. All of your assets that you think are real can go away just by unplugging a couple of data centers. So how do you make sure that you are confident while using internet on a day-to-day basis, but at the same time you know that you can actually own everything you're floating on the internet? It's exactly what MOI tries to solve for by having millions of nodes in the network. Not one, not 100, not thousands. This is our goal. Okay, thank you. But we'll learn more about that later. These are some things for you to pick your brains on actually. I'll not go deep into each of these slides. But I'll quickly ask a question. How many here may have an answer to my question? Like how many smart contracts are there on Ethereum mainnet right now?
30K. More than 30K.
30K? Okay, very small number, but not bad guess. Anybody else want to take a guess? How many smart contracts are live right now on Ethereum mainnet? Give me an average guess. 50,000.
400,000. 400,000.
Smart man. You have read it from the slide and you're giving it to me? Yeah. So, Ethereum, the world's supercomputer, global computer, so called, right? We adore it, use it on almost day-to-day basis for almost, 2 to 3 different use cases like DeFi, NFTs and community stuff, right? Ethereum has less than 500,000 smart contracts on the mainnet right now. So, what this tells us is that we are still freaking very early in this space. It's not as if we have an established player who is currently used globally to a scale of billions of people and millions of institutions are using it. It's not like that. We're still in very early in this game. That's something for you to think on and ask yourself, right? If there are billion people tomorrow and each one of them will define at least one asset on their own, will Ethereum be able to handle billion smart contracts? Ask this question, that's a homework, and then find answers in this slide later on. Next question. How many here have used Uniswap, KaibaSwap, SushiSwap, any swaps, DEX basically? Alright, I can see almost like 50 to 60% of the people raise your hands, right? Can anybody tell me how much Uniswap makes every week in fees? It's in the orders of millions of dollars. And this goes without saying that Uniswap's before router now has something called protocol fees, which they are planning to introduce in December, which means that there's going to be more fees on top of Uniswap when you exchange your assets, right? And this is happening with very few people already using Ethereum. Imagine if Ethereum scales, if at all, right? And then billions of people want to trade like millions of different types of assets, if not trillions. How will we sustain economically if we end up paying millions in fees, right? Today it's all happening because you are swapping some NFTs and you really don't mind paying a $1,000 fee, $5,000 fee for a $1 million board ape NFT. But tomorrow the situation will change when you start using it at Starbucks, right? So this is not a sustainable model. Instead, the network itself should give you an intelligence to find a buyer and seller instead of always relying on an aggregator. Aggregator is not your first stop for search. It should be your last stop for search. Try to find more answers in this slide later on. But Ganesh, all this is good, but how can you make all of this happen at scale is going to be the question, which I will try to answer and I will leave it here. Right? Nobody is talking about the real differentiation needed between a $10 Starbucks coffee transaction and a $1 million property transaction in Goa, let's say. Right? So, if let's say I own a rental property here in Goa and somebody here is willing to give me $1 million. So, if you give me $1 million worth of stablecoin or crypto, and if I just tell you, bro, this is the key, take it and go, is the sale actually done? From a domain, real estate domain, I think. Signatures are needed, and once signed, where it should be taken to? Hold?
Payment transfer.
Okay, payment is done. Payment is on blockchain. Now, what should I do next? Should I just take the key and think that this is my house?
No, paperwork is required.
Paperwork, exactly. Who does paperwork? Who does real estate paperwork?
Government.
Government. Which authority exactly?
Court. There's a court.
Department of Revenue and the sub-registrars, basically, right? I need to go back to the sub-registrar and there's an officer sitting there who will say that, okay, show me the proof of payment, show me the proof of ownership, and then I will keep it in my records that Ganesh sold it to you, Chaitanya. And Chaitanya, you paid Ganesh $1 million worth of some crypto on some chain. And here is a proof. Ganesh agrees to that, right? This process, people think will automatically happen in blockchain today. But Sub-Registrar Garu is telling me that I need a private blockchain network where I will keep all my land title records on some sort of a framework. So basically, we are at a disjoint moment right now where technology is actually not meeting day-to-day business demands in blockchain. So let's solve for that. How will MOI solve it? I'll explain that quickly and then I will give it to Manish. When Alice is trying to pay $10 to get a cup of Starbucks coffee transaction, that transaction does not require the entire network's trust. Again, do we need everybody in the Bitcoin network or everybody in the Ethereum network to know that we just made a $10 transaction? Is it worth it? After that, paying $20 and $50 as a result of it, it just doesn't make any sense. Whereas, yes, if it is a $1 million transaction, then your trust must be very high, and the network must offer maximum to maximum security to ensure that nobody is fudging numbers or titles here. So you need maximum security and let it go through as many people as possible. But what if it's a business which is hosted in United States soil and they come under compliance of the Department of Treasury, which basically maintains something called OFAC, which will basically sanction companies when they are doing business with any non-US sanctioned countries. Will blockchain solve any of these questions right now? What do you guys think? If I am signing a transaction as a US company, there is a high possibility that it can go through a node which is sitting out of Iran, yes or no? Iran is a sanctioned country as of now, at least, yes or no? So the people who are involved in the transaction, the signing parties, they also are now liable to sanctions, yes or no? Basic logic, transitive property. Again. So blockchain does not have answers to these real business questions. So far what we have ended up having are small applications which can test the basic functionalities of blockchain. But if you want to build your next big unicorn, right, then you need a chain which can address all of your short-term as well as long-term business requirements. So that's what MOI does. MOI gives the ability or the flexibility for you to choose a couple of things, right, with the help of something called context. We will talk more about that later on. But think of context as there is a Twitter user and then there are a bunch of Twitter followers. So basically what ends up happening is when a Twitter user posts a tweet, all followers will get a notification that this person has tweeted, correct? Similar to that, how context works currently in MOI network is that a bunch of nodes who are following your account will get a notification in Boxer format saying that, boss, this wallet has signed a transaction, you guys want to get involved in this or not, right? And then these nodes will come together and then settle this transaction. Here you can have certain degree of flexibility as an application, and you can define that tomorrow, if you guys work for Starbucks or if you get Starbucks as a client and build your dApp for Starbucks, you can ask Starbucks that, bro, what is the level of trust you want? And then they will tell you, just involve the context nodes from the user who wants the coffee and involve the context nodes from Starbucks, which are just Starbucks office nodes and a bunch of other nodes. And then bring these people together to quickly solve the $10 transaction. The whole world need not know about this. And of course, to make sure that nobody is colluding here, what we do is we add a bunch of random nodes into this consensus to make sure that there is no collusion, and this is how we provide network security. Now, this is the underlying mechanism I'm trying to flip it real quick for a $10 transaction. But then Ganesh, a $1 million transaction needs to go through something like Bitcoin or Ethereum because they are the OGs who have maximum network capacity, right? But what if I told you that I can provide you more network capacity than Bitcoin and Ethereum combined together, and at the same time give people like government bodies, like regulatory authorities, like the sub-registrar offices, to also get into real estate transactions. That way, a sub-registrar running a public loan need not actually settle a transaction for a Starbucks coffee or purchase of a chewing gum. Why should a sub-registrar do that? We should only be focused on evaluating real estate transactions. So put together, this is the kind of flexibility that MOI offers. I will just quickly wrap it here, and there are a couple of other things which explain our ecosystem and other things. We will take care of this later on. We've been around for a while now, and we've been building some really cool apps. Our founding team member and core developer from MOI Protocol will now be giving you a session on CocoLang, a new smart contract programming language built from scratch for real world applications. So are you guys ready?
Yes, sir.
Hi. Hey guys, I'm Manish. I'm one of the co-devs here at Labs, and among the people who's building the MOI protocol. Right? So obviously, getting a chance to get into how MOI works and some of the implications for what it means for our next state vision, for what we're trying to build as what we call the stateful internet. Right? That's the fundamental vision of what we're trying to build, and kind of with that. So I'll kind of gloss over what it means for you guys as developers, what it means to build on the stateful internet. What kind of gains can you expect as application developers, and simply even as just builders, what kind of fun can you have, and what kind of new use cases can you build for the emerging industry interacting with, right? So just a little bit about myself. So I'm one of the founding members here. I'm the co-protocol dev at Labs. Along with that, I'm also the creator and the lead dev of the protocol which we're learning about today, CocoLang, and the runtime it runs on, which is PISA, which is analogous to the Ethereum virtual machine, and Polo, which is analogous to RLP, which is our in-house serialization that we built to be equally efficient as protocol buffers, just as fast, and also canonically serialized data. Right? Something that protocol buffers cannot do. We're not going to talk about it today, but still. So a little bit about MOI. My definition for MOI, of course, is that it's a context-aware peer-to-peer protocol enabling the fabric of the stateful internet. Right? So the stateful internet is an idea that we touted in Labs as being the cornerstone for enabling a personalized digitally interacting world. Right? The internet is made up of people interacting on it, and today peer-to-peer technologies are more about nodes and machines talking to each other rather than people. Right? And people and individual assets, they all work still even though we're working on a distributed framework. Ethereum in a lot of sense is still centralized, right? Think about your assets, right? Your ERC20 contracts. They're just ledgers which are centralized again, because only one person can talk to a contract at a time. Yes, multiple people have to participate in the approval of changes, but it's still only one contract, and everyone has to wait in a line. Is that really decentralized? It's not, right? So some of the key benefits of what you get with one, of course, is these are the three big ones. Right? Infinite scale network that grows forever, right? And it's a network that grows forever and becomes faster as it grows, right? It's not a network that loses its performance as it grows, like most other blockchains today, right? It's a network that can scale infinitely, and as it grows, it gets faster and more hyperparallel, right? The point is that if me and Sarthak are talking to each other, and let's say Rahul and Ganesh are talking to each other, why should we have to wait for each other to today in Ethereum blockchain or any blockchain for that matter, they need to be ordered sequentially, regardless of the fact that they're not bothered. The fact that me and Sarthak are talking in Goa versus someone else in Bangalore, should that really affect you? Why should you have to wait for someone completely irrelevant to your context? Right? And all that is done with what we call lightspeed finality, which is achieved using our new state-of-the-art consensus algorithm that relies on participants, interactions, and all these parameters that we're talking about. Right? So the fundamental point here ultimately is that all of this is done using what we don't just have something called smart contracts, right? In MOI we have three primitives that we call native values, and those are assets, logics, and files, right? Today on the testnet available as assets and logics, and files is a feature we're building in for the next testnet. So the purpose here is, like as I've written down there, right? So MOI enables participants, which is being participants of the network, through their context, being context of the network, to interact with each other, being a network that enables digital interactions, to communicate with each other in a truly creative fashion, using native values such as asset, logics, and files. Right? All of these assets, logics, and files, these native values, they're owned and managed by the participants who created them or are interacting with them. Right? And each of these native values can be manipulated and interacted with concurrently without needing to lock each other. Right? This whole paradigm brings about a new era for sustainability, personalization, and scalability. Right? So the way this works is like there's an illustration there on the side, and you guys can take a look at it, but I'll break it down for you piece by piece. In Bitcoin, you notice that most users of accounts basically just have a balance. Right? I have 10 Bitcoin, and that's about it. There's no smart contract usually, there's no layer 2 layers with money. In Ethereum, let's say now the whole purpose of Ethereum is to let's open up millions of assets, let's make possible the idea of assets. Right? So, but the way we do that is that there are central registries like the USDT contract you're seeing there, which have the balance of multiple participants. If somehow USDT got hacked, potentially multiple people are at each. Right? And my balance is not really my balance. My balance, the only balance in Ethereum really is my ETH balance. All the other balance are just technically program variables. Sure, decentralized, sure, we have like safety measures to make them feel real, but are they real? And it's not sitting in my work. And even further, let's say I want to do something like approvals, right? I need my ERC20 contract to have approval capabilities, and then I need to use some central service to essentially manage my approvals. All of this is not really scalable or not really native assets. And the way MOI manages that, and the reason why we call it native asset, is that within your balance account, within your participant, right? Let's say right there's a MOI participant, he has three types of balances. He has spendable balances, he has approvals, and he has lockups. That's a new idea that we're bringing in. The idea of spendable balances is that you can have all the assets that we create in the protocol, they're all in your wallet. So the same participants can have, multiple participants can have USDT, MOI tokens, Ethereum tokens, Bitcoin, whatever MOI variant tokens are there. Those tokens are sitting in your wallet. They're not sitting in some central registry somewhere. And you don't have to worry about it. And that means if I'm transacting to someone, I just have to transact with him. I don't need to go to a central registry. And that means thousands of people can transact that same MOI token across the ecosystem all at once. No one has to wait for anyone, no one needs to wait for the smart contract or anything. Similarly, approvals work essentially the same way. The approval system is built into the protocol itself. It's not something that smart contracts implement. Right? The approval layer is built into the protocol's native asset capability, and therefore you don't ever have to worry about implementing the project at all. And lockups is our answer to a lot of the common attack vectors around things like staking contracts. Right? So today, traditionally, when we even take Ethereum staking contract, there's millions, close to billions of dollars of sitting in that contract. 32 ETH per validator, it's all sitting in it. Right? But if someone managed to hack that contract, say some vulnerability, there's potentially so much value lost. Right? The way we avoid that is that we work within the real terms. If you want to get a credit card, you go to the bank and say, here is $1 million, give me a credit card for 10 million. Right? No. The bank says, maybe put an FD. I just need a lockup. Right? Put an FD, it's your money, but it's in my bank. So what we can allow is for logics, staking logics, and contract logics to effectively lock funds in your own wallet so that you can't spend it, but you can't move with the funds either. And at any point in time, the logic can come back and convert that, remove that block. Right? You can ask the logic to free and unstake effectively. Right? So this paradigm, this ability to have all of these capabilities, protocol-based transfers and logic control locking, is native in the protocol. And this basically what that means is you no longer need to write a smart contract to create a digital asset. All you got to do is file an interaction and simply tell the protocol, create a new asset. Right? And that's as simple as writing this piece of code. Right? with our MOI DevX Goa, that's all it takes, right? You notice all we're doing here is we're creating an asset. We're using the interaction type asset create, right? Setting a fuel price which is today 1 and the fuel limit let's say 200. It costs just 100. It just costs 100 gal fuel in today's testnet fees to create this fast spinning, right? And I'm creating an NFT essentially called Candyland with a standard called 1. I'll get into what standard means in a second. But a supply of 1, I create an NFT called Candyland. I fire the interaction, I wait for the response, get the response, interaction hash, and I wait for it to be finalized. That's all it is. So what these standards basically mean is that today in the testnet we just have 2 standards, MAS0 and MAS1, which are analogous to ERC20 and ERC71. So those are the NFTs and your regular ERC20s like fungible tokens, right? So all you gotta tell the protocol is what standard of asset you want, tell the supply, give it a name, and done. You have an asset ready to go, and now it's in your balance, you can transfer it to go. Right? That's all it takes to create an asset. And as assets as far as assets go, these are the interactions that are available and the ones that are coming soon. You can transfer assets, you can create them, and you can link and learn the assets which are MAS0 standard. MAS1 is obviously being non-fungible, cannot be maintained. Right? The idea behind this standard model is that tomorrow we can extend it to 3, 4, so on, with different capabilities, more interactions are managed as capabilities. Right? All of the protocol, you never need to write single pieces of it. But if you really wanted to, let's say you had use cases that needed that, you could write logics that live alongside the asset that could regulate some extra behavior, right? Transfer only if under certain conditions and so on, right? But most of the time, 90% use cases that require an asynchronous logic don't have anything. They just copy the open contract and then just publish it, right? So our goal was to get to those use cases. Most people just need to fire a bunch of assets. They need to create hundreds of these entities and tada, you're good. Logics, the second type of data values that we have, are similar to smart contracts. They're kind of code execution. But in MOI, what we do is we isolate the logic execution from the interaction execution. Right? In Ethereum, that's like smart contract versus transaction. Right? What that means is, today in Ethereum, the EVM does the whole job, processing the transaction, validating it, and then executing the code inside it, and then performance check. Everything is done by EVM. In our case, we decouple this so that the actual executing of the logic code is independent. And that means now we can support multiple different types of runtimes. One of them today is what we call PISA, and tomorrow we have designs for things called Mero and Hanoi, right? And we'll talk a little bit about them in a while, but Mero and Hanoi are future runtimes, and potentially tomorrow, let's say we find a security bug with PISA, and we want to upgrade it. PISA V2, there's another engine. In Ethereum, we can't do this, right? We have to restart the entire network with Ethereum Virtual Machine 2 with a completely new protocol, because existing and old transactions will no longer come. Right? So this is great for security, great for scalability, and great for extensibility, and this is where the Confluent MOI can be the incident because it's extensible for them. Right? You can keep doing new runtimes. The last part of what we introduce with projects is a new state paradigm. Right? We have persistent states and ephemeral states. Right? Name sounds interesting. Let's dive into a little bit of what that means. Right? Persistent states are basically what you have today with smart contracts. Right? The funds and the state associated with the logic are bound to the logic itself. Right? The smart contract. So anytime you want to change it, the smart contract needs to update some internal data in its account. Right? But ephemeral states basically open an option to have states that bind to the participant itself. Right? The data never is linked with logic. And that means the state that the logic is manipulating is attached to the participant talking to the logic. Right? And this way, now millions of participants could talk to the same logic, because the logic is no longer stateful. It no longer has a state that it needs to talk. Thousands of people can talk to the same contract at the same time, all concurrently. Right? The implications of this ephemeral type state design is right here. Right? So imagine a CAP service, right? I'm calling it CAP hailing there at the bottom of the black box. And let's say it has 2 invocable functions. One's a book ride and one's accept ride. Book ride is me as a hailer, and accept ride as me as a person who's trying to drive away. And at the same time, there are 2 enlisters. We'll come to that. But let's say I am a driver. Like I signed up with the service. I want to register myself. When I call the registered driver's method and become a driver, the logic will write into my state that I am a driver. You see how it's when I'm a driver. Right? And next, every time I talk to the contract, it will have access to the reservation. It's never inside the contract itself. The contract is stateless. Similarly, when I'm a new booker, like when I join, let's say, Uber or whatever the app is, when I register myself as a hailer, I get this capability. So now every time I book a ride and accept a ride, the data that gets manipulated is the data inside my state. So thousands of people can talk to the same logic. The logic just mutates your participatory states, not the state that's inside it. So there's no need for central lock, right? And that means you get concurrency. Millions of people can talk to the same logic. Uber can really exist on blockchains now, right? Millions of people can talk to the same logic without having to wait for each other. Because the app is basically effectively a digital, you're truly building a global computer at that point, right? And data privacy is the second implication of this, the more important one in my opinion, is that the data never is in the logic. Unless you choose to interact with the logic does not have access to the data. Logic can't just sell your data to advertisers. It's with you, it's your data, right? So these are some of the implications of ephemeral state design, and this is what we as MOI expect people to move towards over time. We expect that today's way of smart contract development will basically die out. And that building ephemeral state design, where you get massive concurrency and data protection, this is the real Web3 way of building projects, right? So when it comes to logics, just like assets, today we have the ability to deploy and invoke projects, but we also have the ability to eventually, today ephemeral states are not supported in Dalna, we only have persistent state. So we have this impact for the future and upgrade, which will allow you to upgrade the addition of the logic. Today, at the protocol level, we support additioning of the logics, but that means you can't just change the logic to become whatever you want, and extend its capabilities, extend its state form, right? You can't just change it or completely. But that's the way we support it. But yeah, so if you want to get started with developing MOI development, this is the website. You can take a picture, you can scan QR code, get on our Discord and figure out how to get started. Voyage is our explorer, which will allow you to interact with the protocol, figure out what kind of blocks are currently being generated, we call them test apps, what kind of interactions are currently being run on the network, and you can also fire interactions and send logic calls and RPC calls straight from the explorer. It's not like the explorer if you look at it. The docs are available at MOI.Technology, and the JavaScript SDK is currently open source and available on NPM for you to get happy with it. Okay. Let's take 2 minutes. Hi. Anybody have any questions for me at this point? Alright. Okay. Sure.
Talking about the standardized law, base law,
Sure.
and this transaction of say $10, it's going to be realized.
Yep.
But how come
Okay. So the way we were not exactly planning on talking that deep into the protocol here, but the way it works is every single participant effectively has their own chain, right? And all these chains are maintained by every single person, every node in the network, right? So at any given point in time, all the nodes know what Alice's current state is and what is Bob's current state. It is the entire tesseract or the block on Alice's network on her chain has Alice's current state and Bob's current state. So when Alice and Bob talk to each other, the protocol only needs to lock Alice and Bob's network context, make the transfer, and then disperse the state across the network. Right? Of course, propagation has to happen, but the way we do it is that this local finality that we talk about, the way it's special is that we choose something, we have a special set of nodes for each participant called context nodes. Right? When he's mentioning this, these context nodes are, think of them as your family. Right? Today, if I want to know something, what's your good name? Rajesh. So let's say I want to know something about Rajesh. Who would I go and ask about you? Probably you, but let's say you're not available. And I can't trust your information. Who would I ask? Your employer, maybe your family, your children, or your spouse, or something like that. Today in Ethereum, the way that works is I go to some random dude in Siberia and say, do you know Rajesh? And I just keep going to every house in Siberia until someone says, yeah, I know this guy. Right? Brute force search through the network is what we do today in Ethereum or most distributed systems. The way we do it with MOI is there are these context nodes who you can think of as your family, your friends, your relatives, who are most likely to know who you are. So when I want to know Bob's latest state, the people I can trust without failure are Bob's context node.
If you compromise Bob's friends, you can compromise everything.
Technically, if you compromise Bob, that's better. If you compromise Bob's friends, you only compromise Bob. Everyone else is with them. Right?
Bob has say 10,000 coin ones, I want 10,000 coin ones,
Okay.
and compromise friends.
Yep, but the way it works is, in order to do that, so the security measure there is that we don't just rely on Bob's. Let's say you rely on Bob's, we rely on Alice, and assuming even they all collaborate, we still rely on 1/3 from the network randomness. So in effect, you can never really game it because network randomness is truly random, can never be gamed, and Alice and Bob's randomness are picked at the time of consensus. So you could potentially, you're right, I could potentially affect both Bob and Alice's nodes, but they compromise less than 2/3 of the consensus set. So they'll never really be able to compromise.
I'm not talking about $10, but I'm looking at $1 million.
Of course. So that's all. So when Ganesh mentioned that we can have a different kind of transaction for $10 versus $100, like $1 million, let's say, you have something called trust quotient in the protocol, which you can adjust to determine how big the randomness is. So if let's say $10, you just want to get it done quick. Lock up Alice's context, lock up Bob's context, get another 20 more nodes, do the consensus, you're good to go. But you're doing million, you can say, apart from Alice and Bob's context, I want 10,000 nodes. That's how you can ask the network, I will pay more gas fees, give me more nodes to prove my transaction. Right? That's what we mean by ability to provide different kind of transaction experience that you don't get in Ethereum or in Ethereum or Bitcoin. You only get in one. Right? Yeah. Great question, though. Anybody else? Alright, okay, let's get going. So, talking about Coco, this is what we're all here for today, so let's move it along. Right? So, what is Coco? Right? Coco is basically a context-oriented and static type programming language. It's pretty high level and intent-based, so it's Pythonic in nature, so it's very readable. Right? It's a language as a whole. It prioritizes readability, auditability, and safety. Auditability being a very important point, right? This programming language was designed to prioritize the auditors being able to catch problems more than developers being given more power, right? Developers have, it's like almost like you're on rails at that point, right? As a blockchain programming language, the job is not to give developers infinite access to this thing, right? But rather to give them control so that they cannot make commonly occurring mistakes, right? In Coco, it's basically impossible to make an integer overflow, right? Because the language won't let you. Language will let you know you have to catch the exception, right? In Ethereum, it just happens. You have to know to catch it. If you don't, nobody gets out. You basically deploy the chain and then you basically waste a lot of money, right? So the language helps the developer write safer code, and it also makes it easier for auditors to catch mistakes. We'll see all that as we go into building. But more importantly, we also build Coco to prioritize stateful runtimes like Lisa. The fact that there's a participant, there's space, interactions, context. These are all native objects available in Lisa and then by extension to Coco also. Right? And obviously we developed it to be able to design and develop projects for them. Right? You can obviously check out the website at CocoLang.dev right now. So I mentioned a little bit about what Coco is, but why do we need a new programming language? Right? Most of you, I'm assuming, are Solidity developers, right? So can I get show of hands for devs who know about Solidity? That's looking like 50% of the okay. So would you say you're happy writing logics today, smart contracts today on Solidity? Show of hands. Okay, definitely do. Alright, so effectively, I've never been much of Solidity dev. I kind of pick it up as a necessity to kind of figure out how this should look like. But most Solidity devs that I have spoken to have never been happy with their product experience. And more importantly, the whole point of blockchain and distributed smart contracts is someone wants to be able to verify that the code does exactly what it says. It's almost impossible to learn Solidity unless you're an expert coder. That's why we have auditors. There are companies built around that, right? It's become a nightmare now. I gotta make sure my code is safe. Because there's millions of dollars going through that contract, right? So we wanted to build a programming language that took care of these things for developers and auditors, but also because MOI opens up so many new capabilities. Ephemeral states, we have participant-based interactions, context. All of these primitives need to be available in the programming language. And that's another reason why we built Coco, so that it can faithfully give you those capabilities. Right? And like I said, CocoLang solves problems by giving you a lot of these primitives. Right? The participant called sender is literally a super global available. At any point, you can access the sender's full context because he's now interacting with you. It's like once I touch you, like you've seen Avatar where the two people kind of find their thing on their head now. So when it's like that, so when the logic and the participant have bound each other, I should be able to access everything about the participant. Right? Obviously the participants can set rules on what accessible and not. But the fact that I have access to the participant, it balances the assets that he wants, all that is available in the runtime. You can access all of them. Right? So CocoLang helps address those things. And that's exactly what I mean by context-oriented programming. It's not just another gimmicky word to add on to object-oriented. It's the idea that resources like assets, objects, and files, these are tangible programming concepts, right? And beyond that, it's a language that is designed to enable this kind of ephemeral state programming and so on, right? That ephemeral state programming is so new, it's just not possible today for any programming language to deal with ephemeral states, right? It's quite complicated and tried, trust me. Right? So Coco is that language that we built to enable that capability and to open up this paradigm that we call context-oriented. Right? And all of Coco's programming needs to run on some runtime, and on MOI today the available runtime is the PISA runtime. It's basically a register-based virtual machine for stateful execution with primitives like interactions, participants, and context. Right? We're going to see what the bytecode for it is. Right? But the reason we went with the register-based bytecode is because register-based machines generally are much more complicated to build and maintain. Yes. But the reason we chose to do that is because the number of opcodes, and I'll share that a bit, generated by register machines are much lower, right? And it's much easier to manage the virtual fuel cost, right? It's much more manageable fuel cost because the number of opcodes are lower, and the reason that they're lower is because each opcode does a lot more. In Solidity, EVM basically you effectively need 20-30 opcodes just to read and input data. It's just one opcode, right? So the 20 opcodes is what we usually take in stack machines can be compressed down to a single opcode in a register machine, right? And the compiled artifact that we get in Ethereum will generally deploy just your bytecode, right? And the bytecode is on chain, and you can verify. You have to decompile the bytecode to see what's inside. With MOI, you don't need to do that. When you compile for MOI, you get an artifact called a manifest, and this manifest is a human readable file, JSON YAML. But the version that you deploy to chain is not readable, but you can encode it in a human readable format with just a simple utility. And this manifest contains not just the bytecode, but also the API. And unlike Ethereum or most development platforms today, where the developer is supposed to give you the API so that you can talk to it, you can pull the API from chain. The API exists on chain as a verification of what the interfaces for the logic are. You can't skip it. It's not possible. Developers have to make it in. All I got to do is use the logic ID, and I can go away the manifest anything. Right? You'll see that in practice, but take this very simple simple contract. I'm sure when you guys all started, you would have seen this contract at some point, right? This extremely simple simple contract and so on. Right? We're going to build this contract in Coco to make the point, but just wanted to show you what the compile effect is, right? If you compile this contract Solidity using Solid target with BDM, you're going to get 443 opcodes, and that's totally 633 bytes, right? The generated artifact that we do deploy to chain ultimately is just the bytecode, and that's 633 bytes, right? If I do the CocoLang and Solid PISA, that's 18 opcodes, just 471 bytes, and that artifact contains the ABI utility. Right? Not only is it smaller, it's more detailed, and it's safer for developers to use this artifact because it contains the exact interfaces that are verified on chain. Tomorrow, a smart contract developer could deploy something and give you a wrong API that makes an invalid call. That it is hidden because the API that he's giving you is potentially punched. But if you do that, it's not possible because the SDK always pulls the API from chain. Right? So you don't even need to make an API file in your repository. Just for like readability at that point, right? So we're going to start building that exact triple contract we just saw in Coco. So I would appreciate if everyone took the time to start building. So you can go and it will take 20 minutes. We'll help you out to get Coco installed. So just head to CocoLang.dev/install and you can install CocoLang. It's quite easy. The install instructions are available. Let me know if you guys can go through your laptops. I would appreciate it if you don't try to code along.
Guys, if you want to connect to the Wi-Fi, go to Accor's link, and in Accor's link, then you will see the box that will pop up. There you have to go to internet access code, and then in that internet access code, put the code that is given to you. Okay?
This is hello to
If you will have internet, right? simple thing I would say.
Also, right now, the VS Code extension is also available, so you can download that in your VS Code. And yes, that's what we're building more.
Wi-Fi? So now we are getting the installation period for
if you want to develop Let's not take that chance. Yes, some standard.
This guy, 7-zip doesn't extract in Windows.
7-zip does usually install that.
Doesn't Windows.
You have the zip.
I tried on this Windows. Yeah, I'm going to extract it in my PC and zip.
Okay, guys, show of hands who has their stuff installed ready to go. Anybody still waiting? Needs a little more time?
I'm doing it first.
Okay. If you need more time, like, I just need a raise of hand, like show of hands, so we can give you a couple more minutes. Okay. Okay, looks like we're good to go. Guys, take it here. So let's open a new, VS Code project, company name, whatever. Let's call it Flipper, right? Okay, so we'll open my new project here. Let's start with the first new file. Just all things is new file. Let's just call it Flipper extension. I have the extension sorted, but if you do not, you can head over to the extension marketplace, search for CocoLang, and you should be able to find extension. Right? We have a new file started, as we go, and feel free to stop at any time and ask questions, right? Let's make this very interactive. If you have questions, we stop, we answer. Alright, cool. So the opening keyword that you need to write in Coco file is the Coco module name and the name. Yeah. Oh yeah, sorry. Visible? Sweet. Okay, Coco Flipper. That's the one you're writing on, right? You need to give a module name. So every module in Coco requires a name. Today we do not support multi-file modules, but if you have multiple files, you need to write your logic. Every file needs to have the same module in the same directory. Right? So next step. Alright, so we need to declare a state. Right? And today obviously we only support persistent state, so we're going to call this the persistent state. This is not the name, that's a keyword to declare that this is the persistent state for the module. In a given module, the logic can only describe one persistent state and one ephemeral state. Right? It can have both, but it can only have one per module. If you declare more than one persistent state, the compiler will throw it. Right? So we're declaring a persistent state obviously, and let's say our value. So this is the solidity file that we're building obviously. So noticing that we have this private value that represents our state. The fact that that value is a state variable and the fact that every time I'm modifying that value is mutating state is very lossy. Right? As an auditor, I can't just come and say, oh, where is state getting mutated? The convention is we use an underscore and then we use these kind of things, but then that's a convention, right? It's not a rule enforced by the language. So in our case, whenever I access the state value, it's known because I access it through the state value, right? I'll show you when we talk about accessing state, but right now there's a value that is part of the state's declaration itself. It's not declared somewhere in the body. right? It's declared as public state, right? And now let's write a function, let's say. Okay. You guys are already developers. What's the first step? Now we have a state. What's the first thing you build for a contract? First function you write. Guys, what's the first function we write in a smart contract? Like when you state a contract. More often than not, it's the constructor, right? So we need a constructor that you call when you deploy this contract, right? So let's build a very simple one. And in Coco for functions which can be called externally, we use the keyword endpoint. Right? And this is a constructor, and it's a constructor. So the endpoint format is called deploy. Right? So this is the deploy endpoint, and let's call it seed. Right? And let's say it takes an input value called init, which is a type bool. Right? And this is our deploy function for seed. So you're going to write a function that is going to mutate the state, right? The way we do that is using a keyword called mutate, right? And mutate looks like mutate. That's how you mutate the state, right? Let's discuss the syntax for a bit, right? Right now you're noticing that first there is a keyword called mutate. Why is this important? Can anyone take a guess? Yeah, that's part of it, but think about the fact that as an auditor, like I just said, I don't know where mutations are occurring. This keyword prevents that problem. Now as an auditor, all I got to do is grep mutate, and I know every place state variables are being touched. Right? So this is great for auditors because now they know exactly every time you mutate a state variable, it needs to use the mutate keyword in some way. We'll show different ways to mutate keyword, but the mutate keyword is essential for mutating state, right? So in this case, what we're doing is we're taking the init value, which is the initializing of the function, and we're writing that into flipper state.value. Any questions? Right? Simple deployment. That's all. Whatever value I set into it, it will see it. Now I've written this value and I want to now get the value, right? Usually we write some getter function on some contract, so let's write that. The getter functions are generally going to be your invocable endpoints, right? So that's an endpoint and invocable. And let's call it get. Any idea from what the context, what we could use to get this out? Obviously, this returns.
Yes.
Questions? Yep.
Not questions. He had an answer to your question.
View function.
Sorry?
View.
Want a new function? Sir, go ahead.
View function.
We don't need new function. There's no contracts in Solidity work like classes, but we don't have the.
I didn't say new, sir. View.
View.
Oh, okay. Close.
Yeah.
You're on the point. Yeah. Exactly. You got it. So instead of view, the exact keyword is observe. Right? So we use observe value, and we're reading from flipper state. Right? So here what's happening is we're observing the value inside flipper state into the variable value. And notice two things. One, for the get function's output variables, every time, every variable, whether that's an input or an output of a function, has to be named. So not using the value word there inside get. This is not valid syntax. You have to declare output value names. Right? And you declare, it will make more sense when you look into the function calling. So inside the website CocoLang.dev, you have a page called tool, where the details are there, the much more complex use cases. We're going over a very simple use case today, which is to highlight the key. But because the value is already declared, the variable is declared called value, I can just read the state directly into the already declared value, and it's already set. In Coco, you don't need to explicitly return values. If you set a variable that's marked as an output value, it's automatically returned. Then you actually return the function. You can use return. You can also choose to do it more forcefully using something like, let's say you want to, you could use the keyword yield, and you can yield value with some value. Let's say you want to return, right? So you could use yield, but in this case we want to yield the actual value that's in the state. So we use observe, read the value of input state of value into this value variable, which is also the output variable value, and it's automatically returned because the function exists in the text line. Right? That's the endpoint. Right? That's your yield. Now let's talk about something like set. Right? Okay. We are doing it with seeder because we seeded the first time, but we want the same function so that we can set at any given point we want to set the current state. Right? So that looks something like right, point set 2, and then I can do rotate, and then I want to use the new value here to set to flipper.state.value, which is copying over the line from previously. So now we can answer the next important question here. Line 13 and line 7 are effectively the same thing. There's different variable. Why don't we modularize them? Let's write a function to do that job for us. Right? What does that function look like? So we talk about using endpoint keyword for functions you can call from outside. But if you want to call functions from inside, you have to declare a function. Right? Func set takes a value and just calls it to mutate that state value. So now instead of using your existing mutate keywords, you can just call the function that does that work for you. So here, instead of calling mutate, you just do set. It just calls the function. You cannot call the endpoint set from other endpoints. Endpoints can only be called from outside. So the way I structure that is that your endpoints are like your REST endpoints, right? And your different types of endpoints, invocable. These are like your post code, whatever, right? And your functions are your internal code. That's where the meat of the logic is. And the endpoint is just there to call your functions in certain order. So there are an orchestration there. Right? The endpoint is just you don't write the business logic at the endpoint logic, right? The endpoint logic is just there to invoke the business logic, right? So that's the same idea. Your function set is your business logic, and your endpoints are your calling logic. That's what you call external, right? And similarly, we can rework your set function to reuse that function, which is the whole point, right? So instead of using the date new, we just call set value. Notice that when we call a function, we call it a function by specifying the name of the symbol, right? In set, the symbol is called value, so here also the key has to have value. Right? Alright. Any questions so far, guys? So we've written so far pretty
Why
simple
is
concept.
it not symbol?
Good question. I'm waiting for someone to ask me this. Why do you think? Take a guess. We have not for set, capital set, and seed, and not for get. Why is that? Any guesses? Mutation. If your state is being modified, Coco enforces that your function has to end with exclamation mark. This is an idea we borrowed from Ruby called danger functions to indicate that something is happening to state there, worth taking a look at. If I'm an auditor, I want to know which functions are modifying state. Those are those functions. If set modify state, I want to know. Who cares about get? It doesn't modify state. It's safe. It's not going to screw up your contract. Set can, worth taking a look at twice. Right? So your exclamation marks work like that. Today we don't support fund handling inside the contract layer, but if you are writing a payable function like you do in Solidity, instead of exclamation mark, you would use any guesses? Dollar sign, meaning that function will take state and can manage funds. Right? So the way that effectively works, the compiler is basically looking for does that endpoint or any function that an endpoint calls use the mutate keyword. And if so, it expects an exclamation mark, otherwise it's invalid. Similarly, if your thing uses the transfer keyword, which is a keyword not supported today, but when you have the asset handling, if you're using the transfer keyword, then it expects you to use a dollar sign. Okay? So mutable and then payable, just like something. Right? That part is quite straightforward. So nothing to worry about. Now let's write the meat of a logic. Any other questions, by the way, before I move to the last piece of our contract code? We need to write a toggle function, not a flip, let's call it. Right? My flip function does not need any input, but what does this function do? What is flip expected to do? Change the current value on the persistent state. Based on the syntax you've learned so far, you want to take a shot at what that would look like. You can suggest syntax backward. have a keyword for observing, we have a keyword for mutating. So, but we don't know the current value. Value could be true or false. How do you know what to set? But you need to read it first, right? So you need to observe and then you need to mutate. Right? Okay. Based on the limited syntax we've learned so far, sorry, I can't just set right because I need to know the current value of the state. And then you need to read that. Yes, you need to read it first and then you need to update it. So based on the syntax we know right now, let's just take a shot at that. Let's call it var current. And it's a boolean, something like that. And then let's observe the value. Right? Right? So we're reading the value into current. Okay? And then in the very next line, we can mutate current to flipper who likes the syntax? I'll be honest, it's a pretty shit syntax, but we have a better one. But this is based on what you know, the syntax for observing and then mutating. So let's take a look at a better syntax that Coco offers, right? We talked about the option to reuse the mutate context in different ways, right? The mutate keyword. So instead of writing what we have here, which requires a variable declaration, observe statement, mutate statement, all that, we can write something called a mutate context, which basically opens mutate. My current value is declared at the time of this, but notice the arrow mark is the other way around. Right? I can do flipper dot state dot value, and I can open an indented context. And in this indented context, I now have a value called current, which has a current state. Right? And now that I borrow that state, and it works like Rust. I borrow that state from borrow the value from state now. Right? Now I can just do current equals flip of current. That's all I got right for the function. What happens here is, at the end of the mutation context, when we exit the indent from 22, whatever the value of current is, returns back to state. You borrow and you return. So now you don't need all this verbosity. That's all it takes to mutate existing one. Right? You can also do observe context, by the way, same logic, but the arrow mark is split. That's the important context. Right? The arrow mark is split because you're reading from state into this and you're opening a mutation context in a section of code where you have this variable. And that variable does not exist outside this code. Right? It exists at that point when you exit the mutation context, whatever the value is. And we also recently just rolled out the support for multiple values. So you can read multiple values from state. Mutate current current 2, flipper to say value 2, whatever. You can read multiple symbols all at once. Mutate multiple values at once. At the end of the context, everything gets written back. Yeah. So yeah, this is our flipper contract, guys. We have written a flipper contract that looks exactly identical to our flipper.solve. Right? It's a constructor. There is a flip, a get, and a set. Right? Solidity expects you to rely on these public, the fact that it's a view function or not, to determine whether it's just a view function or whether it's a mutation function. But when in the way it works with firecon to MOI is that all you specify is I want to invoke a function called seed. Now I don't know just from seed in Ethereum, let's say like I'm making just a set call, I don't know just from the fact that my function selector is selecting set that this set function mutates state. I don't know that. But in MOI, because the set function has an exclamation mark, I know at call side time that the call side has a mutation indicator. So I know very clearly that I'm making a function call that is going to mutate state. Right? Or at least may. Does not necessarily have to. It could be under a condition. Right? So this is your finished flipper contract, right? And anybody is still waiting to finish the contract, we can compile it. Let's take a look at how it looks. Right?
Just a second.
Sure. Okay.
Can you just
Sure. By the way, all of this is available. All of the whatever we're talking about flipper, we just will build flipper, but there is a counter and a token ledger contract available on CocoLang examples. Yeah.
where is it?
The examples, they're on GitHub, CocoLang examples. You can also just head to CocoLang. Yeah. sorry, I'm having an issue. CocoLang.dev/tool, and at the bottom of the tool you have example, go to the examples of code, or you can get to github.com/serverlab/CocoLang-examples, and the examples are there. We'll be adding more as we go based on solutions, but there's simple examples. Okay, all good? Can I proceed?
Yeah.
Sweet. Okay, so in our terminal we have a compiler installed, right? So you have Coco installed. So to compile this, all it takes is just a Coco compile download. Right? That's the command we just ran, and as a result of running compile, you might see we have a new file called flipper.yaml, right? I mentioned something called the MOI manifest. That's your manifest, right? Before I open it, I'll make sure everyone else gets a chance to hit the compile command. Okay. You guys got your compile manifest?
Yes, sir.
It's a flipper.yaml file, right? So if you open it, you're going to see this YAML file that's readable. This is not the exact artifact we push, but if you just encode this in Polo, our serialization format, you'll get the artifact pass. That's your small 443 bytes of data. But if you notice, this is the code that you're pushing to the chain effectively. Just this is in YAML. But if you notice, you're seeing we create a state called persistent, and it has a value field, right? That's clear. And we have a routine called deploy routine called seed, right, which does this code, which executes this bytecode, right? The readable version of that is this, right? Is that one? Yeah, that's the one, right? Seed is value. This is the piece of bytecode that is actually executing in the runtime, right? Look at that. Just all it takes is 5 opcodes, right? The first opcode is basically creating a call function, like an object to call. It's reading the current value with obtain, setting the value of the caller, and loading a pointer which is going to be the pointer to the routine at 0, which we read to be 06, right? So what's at pointer 6? So you see here at pointer 6, we're calling the routine set. So local. So this is a fairly readable bytecode on itself. The bytecode itself is designed to be readable because the whole point of blockchain is saying, oh, I've written some code, anyone can verify. But how the hell am I supposed to verify if I don't understand the opcodes? Now I can just read, the opcodes are fairly simple. Obtain, this is the set function. I'm obtaining the input value of the function and I'm saving it to persistent storage. That's all it takes. It's a very readable opcode set, designed so that blockchain developers can actually verify what's answered. It's easy to say the code is there, decode it, build rules around it. But what's the point? We don't make it easy. Right? The whole point of decentralization and verification is that everybody should be able to verify. Right? So this is the final manifest that we get, right? And this is the manifest that we end up publishing to chain. What the final manifest actually looks like in bytecode is flipper.solve. This bytecode is here. This is your Ethereum bytecode for flipper.solve, and this is your piece of bytecode, the manifest in mode. And if you notice, every function there also tells you what all inputs it takes and what all outputs it takes. This is your ABI, and this ABI is on-chain. This is just not proof Ethereum, right? Because who knows what function signature and function is unless you have the API, and the developer can function the API and send you whatever he wants. You might be sending how many times right? So we built our manifest, and now we want to test it, deploy the chain, and so on, right? So we'll go over how to test this logic and play with it locally with the truffle-like environment that we have on Logic Lab. But we'll do that right after a break. So you guys can go get some tea and
Awesome. So guys, there is IT and refreshment downstairs. So we'll just take a short break. After that, like 10 minutes short break, and after that we'll continue building. Sounds good? Awesome. Leave it as is.
Very last minute. We literally, the release was only a couple weeks ago, first week, and we just pushed everything a couple days ago. Mostly research with, so before always used to use what I had, Python, Go, Rust. These are mostly languages that people use now. Millions of people use. So based on Rust, and Python is like Python, right?
Also, if you want to get break.
Folks, you want to join us for tea? Snacks, veg, non-veg? Yeah. What do you think?
Yes, guys, please.
We have some questions for you guys who are talking. Take questions over talking. Yes, I have already produced one show. Nothing else to produce. So how did it go, sir?
Very easy. So, what's the number? About the larger distance and the link then the word pretty much using
Now that you don't know how to use the play, you don't know how to use it. So choose answers. Because after long you have to do it. How was the response?
that table level.
It's a Tamil engineering college. What about others?
Yeah, there's another way to come up with he's very similar and expert on the for a couple of markets. I guess you don't have to devote based on your others.
But this I think is very difficult actually. Is it not?
Alright guys.
Okay, let's get it started. We will begin. I hope you all had your snacks, refreshments. Don't worry about the merch. We'll get you more. We have a couple more things that we want to give you guys. So just continue, and we'll finish up the build. We want to see some projects. Okay. Awesome. Manish, all set?
Alright guys. Started. So now we have compiled a manifest, right? So now we need to test it. So to deploy to chain, of course, you can take a look at github.com/avalabs as an example, JS example. It's in a repo called JS MOI examples. Then we take this exact repo contract. It's not having networks, so you guys might have to check it out. But JS MOI examples, and there is a fully deployed contract available, and there's a logic ID over there which you can interact with directly or using the tab frontend that they have, right? So, but as developers, we are a little, maybe as back-end or content developers, a little less concerned necessarily about the front end, and a little bit more about does this logic work, right? So we need a good tool to do that. In Ethereum, traditionally you might use hard hat or something like Ganache to simulate a blockchain, right? What we have is, instead of a simulated blockchain, because Coco and generally all the toolchain around MOI designed to be independent components, right? There's a component we have called logic lab. Tomorrow, this will become something called CocoLang. It will be integrated directly into the Coco toolchain. But for now, it's a separate binary called logic lab, which you can just confirm its existence with logic lab help. And it exists here. You should have it downloaded. It comes built in with Coco. Yeah. When you download Coco and install it, logic lab also got installed. So you can confirm that with logic lab H, and that should. So now that we have logic lab going, in order to activate a logic lab environment, we need to first initialize it. So the command for that is just run logic lab init. Right? You can. So the way the lab works is, each individual lab is its own environment, and each environment can have logics, participants, and like almost like a chain effectively, right? But by default, by just running logic lab init, the logic lab will create a default environment for you. So you can just run logic lab init and it will create a default environment, or you can pass a custom environment directly, right? So if I just run logic lab init, it's going to create my environment inside this .artifact directory. You can add it with ignore, you don't necessarily need to commit this code, but this contains your logic lab configuration. So you could have multiple environments, and you could run your logic lab command inside different environments where some logics and participants exist independently. So once you have logic lab initialized, you can start it with logic lab start. If you run start without init, it will fail. But if you run logic lab start right now, this will initialize logic lab in that environment that we just created. Right? If you create custom environment, you have to pass logic lab start -emd and pass the path to your environment. Right? So now we have a logic lab running, and this is like a REPL, just like how you use Python probably. You have a REPL environment that you can play with the logic that you created. Right? So some basic commands to know here is, let's say if I press logic, it will tell me what logics are available in my environment right now. Currently, it's not pushing the logics environment. So let's take our Flipper module, which you have the YAML file, right? You could do this with your YAML file, your JSON file, whatever, right? So something I forgot to mention is when you're done Coco compile, you can pass an F file and pass is it all caps or JSON, and this will generate a flipper dot. So if I run this now, instead of a YAML file, I get a JSON file. They're all the same, it's just different encoding formats, right? So you could also run this with Polo and you get the raw binary data inside this Polo file, right? We'll ignore all that, today we just need the YAML file. So inside our logic lab, once we start our logic lab environment, here to access this manifest file, there is an expression you can write called manifest and pass the path to the manifest. In our case, it's flipper.yaml, right? And then you can type it in different. So the purpose of this tool now is you can read that manifest as in different forms. So currently that manifest is YAML manifest, but I can ask Logic Lab to return it to me as a JSON, right? Or I can ask it to convert it to me, return it to me as a Polo data and return to me as a map. That's your Polo by the way. So yeah, as Vijay just going around letting you guys know, there is a reward for 500 USDT for submissions, pool of 500 rewards for 5 good submissions that we have that use CocoLang and JS.MOI to deploy to our testnet. But yeah, so yeah, you can run manifest as Polo to convert. So basically, you can use this as preposition to convert your manifest between different forms, JSON, YAML, Polo, whatever your file format, you can convert it. And you can use similarly, you can use into to convert the instruction format. You may notice in your flipper.yaml, when the bytecode is sitting inside a section called execute with, you can ask it to be in hexadecimal form or assembly form also. So you just write a manifest and you convert it to assembly like this, and you convert your binary instructions into assembly strings, right? Or you can have something that converts into hex strings, which are maybe possible. Depending on the tooling you need, you can convert instruction to whatever format you want. So you can use this manifest expression to convert the instruction format or the file format of your manifest, right? So that's the manifest format. So there are participant-centric chain, right? So what's the first thing I need before I deploy Logic? I need a participant, right? I need a participant who can deploy, right? So first things first, let's look at what my participant, who are my participants in this chain. So I just go look at participant, no participant found, right? So to register a participant, you just write participant, register, and give them a name. Let's call mine Manish, right? Manish created, and you get an underscore Manish, right? You can also create a participant with a specific address. You specify Manish, and then as, and then you give it 0x and give an address. That for MOI we follow a 32-byte address format, so 32 bytes, right? So you can do that, or you can just create whatever name you want, and it will auto-generate for you, right? Or software thing. So now if I go run participant, I can see my 2 participants and their addresses, right? Now I have a participant, but I need to designate this participant to be my sender, right? The way you do that is with a command called designate Manish as sender. It's exactly like Manish, right? You can literally just say designate Manish as sender and you get the current sender, right? And to see who the current designated sender is, you can just type designated sender. And tell you who the current designated sender. Okay? The full list of commands are all available in CocoLang.dev/tool, so you can play around with multiple ideas. But this is the basic idea. So now we have a designated sender. So now when we deploy the logic, we have to deploy it as this person. You can choose, it will automatically use this. You can overload that later. That feature does not exist today. But tomorrow, despite the designated sender, you can deploy it as Sarthak or deploy it as Ganesh, right? So now we have a designated sender. Next thing we need to do, we have a YAML and we need to compile that with the chain form, right? The way to do that is you do logic, compile, and then let's call this flipper. Whatever name you want, flipper. That's the name we use inside the lab. Logic compile flipper from, and then we use manifest expression and we specify the path to our manifest. Close parenthesis, enter, done. Right? Logic flipper has been compiled. This is the logic address, the unique identifier we have, right? So the thing in MOI is, instead of using logic addresses, we have something called logic IDs. The reason we have something different from address is, as you notice, I mentioned something called computability, right? the same logic deployed to a given address can have multiple logic IDs representing different editions of that logic. Right? So when I update the edition, the prefix linked as 08000 will change to indicate that this edition 0 or edition 1. So now we have discrete logic and that's edition 0. And we can see that in a little bit more detail, this kind of information that we want. Right? Let's go and look at that. Logic. Specify the name of the logic, the name you use when compiling. And this will print out the entire information about the logic policy. Right? The name of the logic is flipper, the address. Notice the address does not have the 0800 prefix. And the logic ID has that prefix. That logic ID is telling you what is the addition, which is 0, what is the current, whether it has persistent state or not. Does it have ephemeral state? Does it have an interactive endpoint? Does it have, is it an ASIC logic or not? All that information is there in that prefix 0800, right? And the address starts from F184, right? So every logic ID of this logic will have the same address, but for every time you upgrade it, the addition will change and the logic ID will upgrade, right? So we can see the full information and we can see that this logic is designed to run on PISA, right? And if we look below, you can see all the available call sites on this logic. All the endpoints we just created, right? You have your get invocable, you have a flip invocable, a set which is your seed which is your deployer, and set in another invocable, right? So those numbers, so by the way, the numbers you see next to the call sites, they're not ordered, they're not serial numbers. Those are meant to be the pointer on the manifest. So that's the actual in the compiled code. Every item you create has a pointer associated. It represents that what pointer in the logic's raw object that area in that code is. The reason this is important, and it's not particularly important as an end developer, but in an implementation, how it works is the EVM is generally, you might have seen, if you write a very large code, it's going to say bytecode too large, right? Because EVM has a limit on how big bytecode can process. The reason for that is the entire bytecode goes through the EVM every single time, right? Regardless of how big a bytecode is, regardless of how many functions you have 100 functions, the EVM has to go through the entire 100 function lines until it finds a function selector it matches. And then it will execute that code. In our case, I can, instead of reading the entire thing, I can just pull get and I can just execute it. That's why we have this thing called dependencies also. So when let's say you call this routine, which is C. So when you call the deployer, I only need pointer 1. But pointer 1 has a dependency of 5 and 0. So I pull 5 and 0. And if you look at 0, 0 has no dependency, so I don't have to pull, and 5 has no dependency, so I don't have to pull. Right? So I can just, if I have a logic which is extremely large, let's say it has 10,000 elements of code, I just need to call one function that only needs 4 or 5 total dependencies. I can just pull this 4 or 5 from the data, yes, and just execute that and throw it. So this is why the PISA can handle much larger bytecodes. Already its bytecode size is much more efficient, but it can also maintain much larger logic. So there's no requirement sometimes to modularize your code. You can write your code in Coco with modularity, but the logic will be pushed into one big artifact environment. Because at runtime, PISA can individually pull elements. So these are all internal details that you guys most likely don't need to worry about. But if you notice, one important thing we see here is it's saying ready false. Why do you guys? We just compiled it, but why is ready false? Exactly. We've not yet deployed the code. We just compiled it, just an object there, right? So now let's deploy this, and we can call one of our deployers. In our case, that's C. And I mentioned something important here, which I just realized I forgot to mention. In Solidity, you can only have one constructor per body, right? In Coco, you can define multiple deployers for the same persistent. What is the point? You see, today ERC20 I mentioned, OpenZeppelin, people just download the code and just push it and call it. What if OpenZeppelin wrote an ERC20 contract, at least 10 deployers? So depending on my use case, I can call the deployer I want. So you can still copy some existing contract which works, and just call the deployer you want to initialize the beginning state. So you can pull a contract called a token contract. It could create a fungible token or a non-fungible token, depending on the constructor you call it. Constructor overloading is not possible in Solidity, and it's a commonly requested feature. Coco has that possibility for you. So now we got to deploy this, right? So how do we deploy? Any guesses? Okay. We want to call the function called seed to deploy. So any ideas? Huh? Close. You don't need to logic. You can just do deploy. Specify your logic's name. Specify the function you want to call. Specify the input. specify the input and specify the value for that input. And your logic is not deployed. And you can see it costs 175 fuel to deploy the call the deploy or seed function. When we compiled it and initially we compiled it, we saw it cost 100 fuel. Right? This is a flat cost for now, we're in testnet, so we're not charging for actual use. Any logic deployed costs 100 fuel, and this 175 fuel is the execution for the seed function. Okay. So you can use the logic lab to simulate your gas cost predictions. You can simulate what kind of gas predictions you can have. That's the idea behind the lab. Okay. You can simulate different types of calls. You can do all that. Right? So now we have seed setup. Now if I run the logic in select on flipper, you'll notice the state has the value. Yeah.
Why we have that not?
Like you said earlier, so he asked earlier, right? So the not function represents that function modifies the state of the logic. So any function that modifies state has to end with exclamation mark. So in Solidity we have a keyword called mutable. It's meant to describe. But instead of using the mutable keywords only there in Solidity, when I simply use the call side only, I'm aware that this call side is capable of mutating state. So that's the reason we added that into the call side here, right? So now when we deploy, you see ready is true because we deploy. But if you try to deploy one more time, this is going to fail because say it's already deployed, right? And if you try to invoke a logic before it's deployed, it will tell you not yet deployed, right? So yeah, you can see everything's changed, and you notice now as stay there is some data. This is the slot. This is the hash of the data that is sitting for the bool value, right? So inside our module we have this value bool, right? It's sitting at this hash. Right? And the way you can generate that, there's a command for this. This is value, right? It's the first one you declare, which means it has an index of 0. So if I want to know what hash, what position the data is in, I can just run a command called slot hash 0 and tell me what the hash is. Notice the hash is 9. That is the computation for slot hash. So if I had more than one field, I could do slot hash 1, and that would be the position of any data written in the second data. Right? So the state would increase approximately. Right? So we did a logic, we invoked it, great, we deployed it, now let's invoke one of the methods, right? So, and logic lab by the way is persistent, so I just exited this thing, and if I do it's still there, right? It's all saved, right? But you can save it by either doing the exit command or doing Control C, either way the data gets saved, and you can modify data. Okay, you can, if you want to do the logic, you can just do logic remove, the full list of commands are available in the on and documentation. Now let's do an invoke, right? So let's say I want to invoke, let's say the get method, right? Let's just go down. Yeah, so flipper, yeah, it takes no inputs. Execution outputs, value equals true. And I'll tell you how much gas down the truck. Now if I did, let's say instead of get, I'm doing flip. Okay, complete. Instead of fuel, get, it's fast. Right? You can test the entire stateful runtime on the CLI itself. And there's no blockchain running like that. It's a simulated blockchain. Right? There's no chain, there's no block, there's none of that. It's basically using a JSON DB, the entire data sitting here. Inventory JSON, all the data is sitting here. Right? It's a very lightweight runtime, so it does not require you to have 10 nodes, get nodes running and all that. It's quite lightweight in that sense. So you can just invoke any method you want, you can get the fuel cost, you can see the execution outputs, and let's look at a more complex use case, right? So this is, we've seen Logic Lab, this is basically the gist of Logic Lab. A lot of capabilities available, you have a lot more utilities for debugging your code, in case you get exceptions from the network, how to decode them, all of that is available in Logic Lab. Let's look at a much more complex use case, right? So let's flip over here, let's look at token ledger control. This is your ERC20 like ledger. Traditionally in MOI you don't need this because you can just create an asset. You don't need to worry about supply balances because native assets are possible. But in case you want to build a legacy asset, right? This is the way you do it, right? It's basically ERC20 written in Coco basically, and we don't have approvals, which is running a simple balance equation. I kept it like it. So you have an endpoint deployer, which is seed, and what it's doing is mutating token ledger state, token ledger supply. Setting the balances to the person who is sending as a seeder. Okay? Notice an interesting thing we're doing here. Sender is something called a super global, right? The same way we access token ledger as a super global, right? Coco2, the token ledger is a logic that we can access, right? Similarly, okay. So this is VS Code, so you get the correct syntax. token ledger is a super global that we access, right? That's a module super global. Similarly, we have another super global called the sender. The sender, at any point in time, you can access the sender if it's invocable, right? You have the address as ownership. Today, runtime limited capacity, you can get the address of the sender by just converting the sender object into an address, and you get the address of the sender. You don't need to do address.message.sender and all that, none of that kind of stuff. Sender direct access. And that's the same way tomorrow if you are accessing ephemeral state, instead of doing token ledger and state.balances, you do sender.state.balances. Right? That's all it takes to affect ephemeral state. So this is your invocable endpoints. We have total supply, we have balance of, we have a simple transfer function. Take a look at this much more complex use of mutate. Right? So you can read from mutation, access the balance value for the particular address, right, which we know, and then you can throw an exception if you want, and then you can set the balances. All that happens is the balances. At the end of this whole thing, whatever happens to the balances gets reverted back to state. Before you push to state, you can continue how many times you want. It's a local mutate. Right? And you can cancel, you can revert back to something, but those capabilities are not available. When burn, very basic thing. So now let's say you made a call and the insufficient balance to burn is there. Let's say the exception got thrown. How do you decode that error? Right? So that's another important thing to know how to do. So let's try to deploy this, right? Cool. So now let's compile this token ledger code, right? So first let's exit. And then let's do this to Coco. Compile dot. Right? That will give you a ledger YAML data here. And then let's CD back because we don't want to re-initialize the logic lab environment. So we can just restart logic lab in the older environment. And then now inside this we can do our logic compile ledger dot ledger yeah, that's the logical file. Compile the manual, right? And then we can now expect has a method called seed. Seed takes a lot more data. Right? As you see, function it takes symbol and supply, it takes 2 fields. So let's illustrate that. Okay, so for compiling this, we will deploy ledger dot seed. And inside this, I will take a symbol. Anybody have a token they want to use? Let's create a token. Give your name. What's your name? Myra. Let's do VMP. Okay. Symbol called VMP, and let's give you a supply of number. I actually don't know how much. 3, 5, 6 digits. Okay. Let's say complete. So it's pushed. So now I can go and inspect the ledger, and there's a lot more data set here now, right? So if I want to see what the current supply is, I have it will be in slot hash 1, right? So that would be right here. I guess this is slot hash 1. So we can confirm that with slot hash 1. EE155, that's the data. This is literally your byte data format. That's Polo encoded. And the way you can decode that is using the Polo library. There is the JavaScript implementation and a Go implementation available for you to decode the data. But let's say you want to decode it here, just for simplicity, right? That's not a capability you have today. If you get an output, if you get a function output like this, you can decode that by specifying call decode. Here's the data from ledger.symbol, and you can say this is the output I got from ledger.symbol. Decode it for me. Logic lab will do that for you, right? So now, but for our case, we can just do invoke ledger.symbol. Not mutation call, this is the call, right? That's the current data. Notice the data there is a big number, it's an hexadecimal. Sometimes you want to see numeric data, right? How do you do that? Any guesses? Yeah, you can convert and all that, but so the way you can do that is there's a configuration in the lab that you can modify. You can just do set x big to false. Currently x big is equal to true. So whatever big integer numbers it gets, it will, because it's big integer because it's a U256. Right. So you want to don't encode them as hexadecimal, encode as a numeric or something. So I can set hex false, and then I can run total supply again. Go change it directly to config. I guess it's a broken command out there, but we'll give it a show you some more visualization. Set, and then you can start the lab again. Let's trim dot. Right, still a big number, but you cannot see it as an integer. Okay, you can use this configuration. Generally speaking, you can use the set command here. Okay, what did I use this for? Yeah, you have my bad. You have to use set config dot expect and then stupid. Right now configuration actually gets changed. Okay. But yeah, so that's the command for that. So now we can see total supply. Let's play with some options, right? So let's say you're trying to transfer to someone else's address, right? Currently the address is sitting inside. Be in my address, right? So we have to go and look at participant. It's sitting in this address. This is the address which has the balance, right? So let's do lecture dot balance of takes simple call address, specified address. That is my current balance. So we confirm this guy. So let's transfer out of this guy to some new address, right? So just for availability, let's do participant. And this is just for participants. Invoke transfer. Transfer takes a receiver and a amount, right? The sender automatically is, so I don't have to worry about that. Receiver. Let's use off this address. Right? Why do you think they're failed? There's an error here. Okay, so there's an issue that happened. Can anyone guess what's wrong? No. Transfer expect receiver and amount. Now only send receiver and send amount. So this is an error. Now let's say you got an error like this, right? If you want to decode this error, you can come to Logic Lab and say ERR decode, paste the error, and then you say you got this from the PSAR extract. You specify that, it will tell you the full exception case. Right? It will tell you PSAR exception, built-in initialization error, invalid input, missing data for amount. So now I can make my original call again. This time fix it. Amount equals. Let's say I do a correct amount, 10,000. Let's say. Just to illustrate the point, less known amount we definitely don't have a balance for, right? So if I throw this, I'm getting a different error. But we're expecting to see this error, insufficient balance for sender. You just copy this error data again. PSA exception, exceptions of type string, error, insufficient balance for sender, root transfer stuff. So inside the transfer function, an error called insufficient balance was returned. Okay. Now exception handling is its own story altogether. But if you want to write custom exception, you can just return a string like this, or you can write a class called insufficient. This is Python, insufficient balance. And then let's say it has address. Type address is the value it takes. In order to make this a throwable exception, so that you can throw this. So the syntax you want to do is, instead of doing this, you want to be able to throw insufficient balance. okay, with some input data. That's the goal you want to be able to do. So in order to do something like that, your class has to become a throw method. And in Python, we do this by having implementing a method, right? Similarly, we just do method. Throw is supposed to take a self, and is supposed to take the self and returns string. Right? So inside this method, you can return whatever the value is. Right? So if now instead of throwing the string, you throw this class, it will throw the error by calling the underscore throw method. Okay? So it works like Python. Similarly, if you want to be able to do something like join, you can join two objects or two classes together. You just have to implement the method underscore join. These are very special methods that can implement capabilities. Similarly, if you want to fire the event, you have to implement the event keyword. And then if the event is there, you can then use your event keyword. Right? Currently, we don't support log events, but you can just use the event keyword to do that. Right? But yeah, that's generally the idea with Logic Lab and some of the more complex constructs. You can use custom classes, you can add methods on classes. Effectively, you cannot have an infinite runtime because there are 255 opcodes, just 256 opcodes like Ethereum. But each class can have another 255 methods. And each class will have a class and class. So you could just keep writing classes and right? There are also other capabilities like signature verification, hashing, all these available. All this information is available in the docs. CocoLang.dev/2, and you can use that to build quite complex applications. If you run into any roadblocks, you can feel free to reach out to me on Discord. And if you have roadblocks with the JS SDK, there's a separate channel for that on Discord. Another team at House will be available for you to ask any questions. Yeah, you know, the floor's here if you want to ask me anything else, right? But that's about it from Coco side, guys. Thanks. If you want to talk about the use cases, we can talk about some potential use cases for you guys to think about building for the reward pool that we have access to. So yeah, some possible potential rewards, you can potential use cases, you can also build whatever the hell you want. As long as it's a good use case, we will try to reward for it.
First of all, to Manish, again, I guess for walking us through Coco language, the motivations behind Coco language, and how is it different from Solidity, and how you can write even safer programs using CocoLang for real-world applications. Now, speaking of real-world applications, I have two announcements to make. Announcement one is that we will be tying up with an accelerator. There's an official announcement that will be pending, but I want to bring it out to you guys first, that we will be tying up with an accelerator who will actually consider your applications, and if you are actually serious about building this at scale, they will fund you, they will give you mentorship and guidance. The name of the accelerator is called Symbiote. It is based out of Dubai. So it will be a 3 months accelerator where you will get access to investors, advisors, and industry experts from the verticals where you are trying to build an app, and receive funding and guidance, and the global exposure you get from a typical accelerator, right? That's one announcement. The other announcement is that I think that is only reserved to people who have stayed throughout and learned this language, right? So we are in conjoint venture with Symbiote, in partnership with Symbiote. We will be posting a $500 bounty, $500, close to 40,000 INR. So you just spent like what, 4 hours here, and you now have the opportunity to stand to win up to like $500 or 40,000 INR. The criteria is that you will have to build some applications in these 5 domains, and we have basically helped you get started with some ideation basically, and we are not expecting an end-to-end application from your end. We all know that it's simply not possible. You have just started learning the programming language and start building application. So we are expecting a bare bone application which primarily focuses on Coco with a very lean front end. You don't have to know React, you don't have to know Angular or Tailwind or Next.js. You don't have to be an expert in all of this, but try to network among yourselves in the room and create groups, and find, if you're a backend developer, find a front-end developer. If you're a front-end developer who can build screens, find a backend developer who is confident of applying their knowledge of CocoLang, and work on any of these 5 industry verticals. We have real estate, we have mobility, we have retail, we also have fashion industry or retail industry, and we also have the healthcare industry. So in any of these industries, we have basically dropped some problem statements at a very high level. We will of course get a more detailed problem statement down the line. But in real estate, one of the primary key issue is there is a new idea called collective ownership. All of us are friends. We would like to buy this party hall maybe, right? So that some of us can come and use it without paying rent or without paying fees for this. You are basically part owner. But the problem is, currently in blockchains we use NFTs to solve this problem. But the fact that we collectively own this place or venue or real estate is not registered with the governments. And this has become an issue in some areas, and this will become a huge issue tomorrow. This is an opportunity for you to become an entrepreneur if you build something on top of this, because immediately your first customer is a government who wants to actually implement this in their jurisdiction. So start understanding how real estate transactions work, try to talk to some domain experts, and if you don't know anybody, our accelerator partner can help you connect with the right folks if they find you interesting, and then work with those real estate experts to understand how exactly statutory compliance are currently in place for a purchase or a collective ownership of a property, and then try to use Coco language to basically bring out that collective ownership of a real estate property. So that's one use case. The second use case is in mobility, right? So a lot of us use Uber, Ola, Namayatri recently launched in Bangalore. All these are really cool apps which helps us from getting from point A to point B. But the issue is, I have been using Uber for a little closer to a decade now, Uber and Ola, and I'm actually concerned that they know where all I have stayed permanently, right? This is not a good idea. Instead, actually, there should be a method in which driver gets to know where to pick up, driver gets to know where to drop off, but after some point they should be able to forget it. Not the driver alone, but even the company should be able to forget it after some point in time, with only just having proofs on the chain and not the exact data like GPS coordinates and stuff like that. So location privacy in mobility digital interactions is one really good privacy based use case you can currently work on. As you all know, Namayatri recently launched. There will be 10 other Namayatris across different states in India, and this will actually scale outside also. So this is again another good category for you to focus on, talk to domain experts, learn the privacy issues today in transportation and try to solve those issues. And then of course we have issues in the healthcare industry as well. So let me take your attention first and ask everyone for a quick show of hands. How many here are COVID vaccinated? Anybody here who has not taken a COVID vaccine? That's fine, you can still raise your hand and say I have not taken.
Everything has gone ahead.
So as you all may know, there are always some or the other sort of conspiracy theories that vaccines like recent COVID vaccines have a direct implication to heart diseases. This may not be true, this may be true, we will not decide that or we will not talk about that. But the point here is, these kind of conversations are happening with new diseases and their new vaccines, right? This is not something new, but with the recent COVID waves, we have learned the importance of vaccines to prevent pandemics, but at the same time, we have also learned that there is not enough vaccine information which is actually going out to people, either to boost confidence or to establish transparency in the industry and also among the masses for a safer environment for all of us. So this is another area where anybody here did a PCMB but did not get into medical but want to still contribute into medical industry as an engineer, this might be one opportunity to fulfill your dream. Work with lab experts who always do drug screening, drug trials, and then try to understand how currently transparency is maintained in the drug formulation industry, and then try to see if you can actually use COCO language to effectively implement transparency in those jurisdictions or in those countries or communities. There are two more industries. I think those are pretty straightforward. Retail mail, I have explained to you that a Starbucks coffee transaction should not take 15 minutes, right? Today we pay in UPI, it takes less than 1 minute to sometimes a little over a second, not a minute. What I am saying is, tomorrow if UPI switches off, what is the next infrastructure, public digital infrastructure we have? We don't have anything. So why don't we build another alternate infrastructure to UPI instead of centralizing UPI and relying on that alone? So try to build apps that you can use in your colleges or in your offices to get a couple of things. And try to build a small retail app around it, like a payment app. That's one POC you can try out. Finally, when it comes to fashion, I've spoken to a lot of fashion designers who actually know more about blockchain than some of our industry colleagues. They have done some deep research in understanding the importance of transparency that blockchain provides for fashion industry professionals. It is actually at two levels. One is that they don't want their fashion ideas to be stolen, and the other is whatever idea they have, they will convert that into some sort of design and they will put it on some fashion weeks around the globe. And what happens is they have a demand to actually prove that the fabric or the materials that they have used in the demonstration is organically sourced and there are no children working out of some remote Bangladeshi sweatshop and stuff like that. So there are some proof systems that the fashion industry currently demands for, and that's another interesting use case for people who like fashion and think that they have an opportunity to explore here as well as an entrepreneur, because fashion is a pretty rich industry. People are ready to pay money left and right as long as they understand the value proposition. So I will again summarize this as there are 5 different blocks of industries. Please try to build something on top of this using COCO and make a submission. We'll give more details about this in a Telegram group, and we already have your email, so you'll get detailed instructions. Make your submissions and you'll be eligible to claim up to $500 in Tether. So yeah, with that I'll probably summarize the presentation. Any questions on the contest?
You have to submit PPT and as well as code.
PPT is currently not a requirement. Submit your code, share as a GitHub link, and explain what your code does in a simple Twitter thread. That's more than enough instead of a blog or a PowerPoint presentation, because you have just started this, so we can keep it real life. So just start off with a Twitter thread explaining what is your idea and how you want to solve it, and then mention your GitHub repo link, and then also send us your GitHub repo so that we can check what you have coded in code. These two are more than enough.
Okay. Ganesh. So now we'll start the networking session. So you guys, if you have any ideas, any help that you need in terms of whatever you have built, we have given you a couple of use cases. You can take these, or if you guys want to build. If you guys want to build your own use cases, more than happy to help you out. Our teammates are here. Manish is here, Sarthak is here, I am here. So now we break into a free session. You guys can network, talk to each other. If there are any doubts, let us know. We are here. We have the room till 7. So yeah, go ahead. Awesome.
So we can have our own use case.
Yeah, definitely.
This is some suggestions.
This is just suggestions.
That we take
If you want to take the suggestions, yeah, your own use case more than appreciated.
Yeah.
But that's the issue. The use case should have a societal impact.
Not particularly. These are just things we know. So from our experience talking to industry partners, we know these are use cases that people want to use. So just some suggestions that we put out there. We're not specifically looking for these. Any use case, early language, it's a young platform.
Exactly.
We don't have a lot of
Even if-
expectations that we have to do in society.
Even if you build something that will help others learn the language better, or create a UX platform where it makes it easier to others to learn about MOI protocol, we'll still take that as a solution. For the designers or non-devs who are here, you guys can go that route.
The point is to get the language out there, to get more people talking about MOI. That's the real goal, right? So what we want is you guys to build tools that help showcase MOI's capabilities better. That's the whole point.
Any other questions? Seeing none. So guys, we'll just gather for one picture. So if you all can just come on. Guys, picture. Please. Awesome. We'll just turn off the.
I will say don't turn off.
Let it be like
Turn this off.
People sit here.
No, I mean in terms of photo.
Some people can sit and some people can stand.
I'll sit. I don't mind. Guys, photo for a minute. Awesome. Guys, please. So one last announcement. So the deadline for your project submission is 19th of August. Okay? Before 19th of August, please try to get your submissions in, and we'll evaluate and book in.
And let us know what help you need. If you
Yeah,
are any
any
other
other-
dev who needs a front end dev, reach out to Abhishek, we'll sort it out.
Yep.
And who have not joined Discord server or Telegram.
Yeah. Just guys, join Discord server. You'll get all the details.
We'll finish that and then only we'll leave them out.
Red meeting is started here.
In the meanwhile, you just log it as well.
Red meeting, it's a very, very small reference.
Yeah, you can. It's okay, it's okay.
Right now it's fine.
3, 2, 1, fire.
Guys, on the count of 3. 1, 2, 3. More! That's a one more. 1, 2, 3. More! purchase, I don't think for sure I will miss a lot. Actually, for the first time I get to know about CocoLang.
Oh, awesome. We have also launched it like very recently.
How long ago?
So you are going to be one of the early adopters.
He's also a data scientist. He's passionate. Machine learning specialization.
Now event everything is 80% of what you need is
You guys can work together and since both of you come
give us a details of
Oh, so you're the one who has it for the
It's about repeat. Actually, just
ஆளுங்கள இருக்கு
Bro.